Thank you very much, Gordon. Always a pleasure to feel all the energy in the room when you're hyping up people. I like this a lot. And yeah, so thanks a lot for having me here. My name is Andreas Petersson. I have a blockchain consultancy company in Austria. I've been a veteran to the... I need a clicker. Thank you. Thank you. I'm a veteran of the blockchain industry, so to speak. I started off in 2011, where I founded Bitcoin Austria, which is a non-profit organization dedicated to informing people about Bitcoin specifically. And I worked for a few years on a popular software called Mycelium. I was one of the main developers there, bringing the first HD wallets to mobile. That was one of the big achievements back then, and a lot of people have secured their bitcoins now with this software. And then I moved on because I thought, well, sending money back and forth is really fun and obviously very useful, but I want to do more. I want to have some real world impact, because money isn't real. Money is just a social construct that we use to operate our society. I want to do something where we have something real that goes beyond that, and that's why I thought having data applications on top of blockchain is really, really useful. And I founded my first startup in this field called Mindbox. We did a few very interesting things, but as it goes in startups, sometimes you hit a brick road, you hit a wall where you can no longer continue, and you have to rethink some of the ideas you had. And that's why I founded Capacity, really making a completely new idea become reality. And we do it in two ways. I will tell you a little bit about what we do. We do a lot of blockchain consulting work with different companies, but then we also develop our own ideas, and this is where I'm going to tell you a bit about the background, why I think this is really a hot topic you should take a look at in general terms. So if you look at today's IT landscape, it's very obvious that there are huge centralization effects in place right now. When you ask a company, are you using AWS? About 97% will say, yes, we also use AWS. And also the other cloud providers are not so far behind. You have Azure, you have Google, and then basically, I don't know, is there anything more that we should mention really? And a few companies operate their own data centers. And of course, this is a huge source of trouble for people who want to have a resilient ecosystem and a resilient infrastructure, because who is really in charge of your data, and where are you going to have your data locked in? This is a problem that many people have pointed out we need a decentralized solution for. And some good progress has been made on that front already. So when you have when you make a backup into the cloud, you create a snapshot of your data, you upload it to the cloud, but this data is not necessarily immutable. You don't necessarily know that if the latest version of your data you are requesting from a cloud provider is really the latest version, or just the latest version that they happen to serve you. For example, if you run into some caching issues, or if the data can also easily be overwritten by human error or by hardware faults, or if or if parts of the data center is cut off from the internet. Of course, and this data is also not implicitly tamper-proof. Of course, there are very good solutions for that to make a tamper-proof cloud storage also. And the most important part, the data is really can be deleted. So when you look at what other people thought about this, maybe let's talk about this first. When you look at the current data center infrastructure, you see that there's a lot of inefficiency. There is obviously a huge potential here to do something about this, because of the data storage that is being used. Only about about double that amount is actually being deployed as physical resources that is possible to use, because there's currently not that many options to utilize these extra resources that are not being used in the data centers. And the same is true for bandwidth as well. You always have a huge overhead, how much bandwidth you have to allocate and how much of that you're actually using. And this is obviously a huge ecological problem, and also, a financial problem. We thought about this problem, and we came up with a solution that that serves a lot of that solves a lot of these issues. What we do is we predetermine how long is certain data going to be available. We use a game theoretic approach to model the behavior of potential hosts that are participating in such a system. And we use these collaterals as a confidence indicator. How likely is it that somebody wants to really store my data for him? And what will be the consequences if they fail to do so? And this enables also the replication of data. I will go into this a bit more detail later. So other projects have really tried to take a look at this and done a really good job at solving many of the aspects, especially surrounding the resource allocation. But some of them, actually all of them, have one big blind spot they cannot solve yet. Maybe you're familiar with some of those projects. There is Siacoin, Swarm, Storj, Filecoin, IPFS, and lots of others that I didn't mention. But those projects have one thing in common. It is either not possible to guarantee the availability of data, or the user itself has the ability to delete his own data. And deleting your own data sounds like something useful you would want to do sometimes. But in practice, if you are dealing with long-term persistence of data, you are potentially your own worst enemy. Because when I have my private keys today, I can commit something to the blockchain, but when I want to protect myself, for example, against ransomware, the ransomware will have access to my private keys. That means this ransomware will be able to delete the data on my behalf without me really knowing it. Or I might change my mind about if I want to persist the data or not. So on Siacoin, for example, the person who is uploading the data has to check all the time, is it still available or not? And this creates a sort of scaling bottleneck. And also it is possible through the APIs that Siacoin provides to delete the data in the system. And also needs constant transactions to happen. The Swarm project is primarily architected as a content distribution network or content delivery network. Swarm, as you know, is part of the Ethereum Foundation Web3 idea, and has a architecture where hosts are talking to each other on fixed routes. And these fixed routes are really great for scaling the bandwidth, but also generate some overhead when you are retrieving data and some extra latency. And there are no guarantees for data to be available on Swarm over long amounts of time. Storj has a sort of semi-centralized infrastructure. They distribute the data across, but then they use a single point for injecting the data into the network. The only way to decentralize it is to have multiple deployments of the same network, which are not directly interoperable. And Filecoin also has the ability to delete the data, according to the docs that I've read. I'm not intimately familiar with Filecoin because it's not fully released yet. Yeah. And IPFS is basically very similar to what services that Swarm provides, but also without guarantee. There are IPFS pinning services, but those are always operated by a single entity. So the system that we built has a couple of properties. We have a live demo that we showed 6 weeks ago in Vienna. Today the presentation isn't long enough for me to include the demo, but maybe if you are interested, we can talk about it later. The system doesn't distinguish between backups and primary data. Because of the redundancy effects, we don't actually need a dedicated backup. And you can also directly modify the data as if it were a local drive. So of course, this sounds contradictory to what I told you before about immutability, but in fact, this is how people use data in practice. They just want to use it like a local drive on their computers, or some other system wants to write to the data. This just means that every time you modify data, there is a new snapshot being made. What we do also is a guaranteed data persistence, independent if you are online or not. From this game theoretic background, there is no single point of failure. We built it with algorithms that are quantum secure already today. With certain limitations on what we can do with it. You have a single key recovery. That means if you lose your data, you just need a single key to actually restore everything that you want. And all the data is implicitly timestamped because you can make a snapshot. The checksums are written on the blockchain, and you can use a reference to the blockchain to restore your data. And it works on multiple operating systems, and it is not tied to a single chain. So we have a reference implementation that runs on Ethereum, but you can also commit to any smart contract capable blockchain. We have clients that operate the same hosts on the public chain and on their private deployment at the same time. So you can have interoperability and have the same data referenced through smart contracts on different chains. So this makes it very flexible. So how does it work from a workflow perspective? There is some renter, they want to store data on the network. They look at which hosts are providing this service for me. The hosts have to provide a collateral, a monetary value as a security deposit. And this security deposit is locked over the entire storage period. And then the host provides this hosting service over this predefined period. If they go offline, the host is no longer accessible. This is checked by an independent smart contract-based verification tool, and they automatically lose the collateral, and it goes into a bounty mechanism. And some other hosts can come along, replicate the data from the redundant scheme, how we store the data, and then the renter can still access it over a very long period of time. So this is how we think it will be used in practice. From, let's say, a mobile phone as a user. You have a mobile device, you have your own local network with a NAS device attached to it in your local network. When you take a photo, it's like 10 megabytes. These 10 megabytes are encoded locally into 3 slices, for example, of 5, 5, and 5 megabytes. So it's a 1.5-fold redundancy. This data is stored on your NAS device, and then replicated to other hosts in the internet. And if you are remote, if you are not at home, you can do the same thing by uploading the data just to the other hosts. They will make a snapshot. This will be observed by the NAS device, and thus when you return home, all the data is already there. And if your internet goes away, you can continue to work on it. You can continue to access it, and this makes it very resilient and also extremely secure, because you do not have to trust any of these remote computers. That makes it very secure. So, of course, this is powered by some algorithms that we developed that make sure that the data cannot be lost, that the data is replicated, and that you don't have too much bandwidth overhead, because especially from a mobile device, you don't want to upload the data 3 times over. You just want to upload it once. This is some of the use cases we identified. We are working with customers who already use this solution, especially in the area of supply chain data. We are working with a steel consortium to make sure that 3D scan data of steel beams is stored in this network, that we can have a chemical composition of these products being stored, and that smart contracts can interact with the chain to determine if those documents are still available or not. You do not have to use external oracles for that. That's built into the smart contracts directly. So it's intrinsic to the blockchain. I think that makes it very elegant. And some other things, we are working with the European Space Agency. So we are part of the European Space Agency business incubation program. And they are our customers. They pay us to figure out use cases, how to store those petabytes of Earth observatory data onto distributed systems to make sure that researchers can access it. And there's also no potential political influence on is climate data good to store or not. Because this appears to be slightly controversial today. And then, of course, some other use cases we identified. We are not using any of them at the moment. We're just working with those two colored items. If you have some good ideas where where is it useful to have immutable data guaranteed over a long period of time? Please, I will put them on the slide, and please tell me, then we can talk about it, of course. Okay, so this is what we did so far. How am I in the timing? Yeah?
You are, I'll let you go over. No, just keep going.
Okay, I will go. So we... Perfect. So we had an idea that was basically, the idea didn't come overnight. It was like we started in 2015, we tried out some things, we really iterated on the idea, created the first thing, threw everything away, and we started really implementing a new experimental prototype end of last year. So we have a small dedicated team of people in Vienna who implemented this. And right now we are deploying pilot programs with special customers that we are already working with us. And end of this year, we are looking to release a public product where that is really end user compatible and that everybody is able to use. What I was saying before, I wanted to mention that the binary encoding protocol that we are using is compatible with Swarm. So we are going to use Swarm as our content distribution mechanism built in. So we are basically one-on-one compatible with what Swarm is providing and providing a complementary service on top of this. So I think this is an interesting topic. This is a topic that will become very hot because so many people are working in this domain. And I think we kind of we put our finger on this wound of this blind spot that everybody has of this inability to delete the data. This is something we wanted to solve, and I think we are on a good track to have a practical solution for it. So if you have any questions, I think I'm finished with Decentralized Trust. We have like a prototype webpage, and I'm happy to have any questions from you. Thank you very much. Yeah, so deletion of data is a very important topic. Sure. Of course, all the data is encrypted. So when I talk about inability to delete, it means the encrypted data is impossible to delete. If you throw away your encryption key, nobody can access this data. And I think this is a hot topic which has, on a legal side, GDPR hasn't been fully thought out yet, because I think GDPR is completely crashing reality with law. There's a clear break here, and usually a reality wins in this case. But in the case of GDPR, this hasn't been decided yet, because when you have encrypted data, you cannot access it if you don't have the encryption key. So what you can do is you encrypt the data, and if somebody tells you, please delete this data, you can throw away the encryption key. That means still the encrypted data is possible to access.
So is there such a thing as proof of loss of encryption key?
Something like this. That can be, for example, done with our hardware enclave. We are working with a very big hardware supplier to provide us with the necessary technology to solve this particular problem, where you have hardware guaranteed loss of encryption keys. Yeah.
Any questions from the audience?
Yeah.
Sir.
Thank you for excellent talk. So a couple of questions. The first one, do you have some numerical examples for user side and for host side? For example, as a user, I pay $10 per month and get 1 gigabyte of data with low reliability and something like that.
Yeah. We have worked this through. It is so that if you are a host, it is likely that you are operating a sunk cost environment. As I explained before, there's a lot of unused capacity. And the question is, if you operate a data center, for how much would you be willing to sell this if you assume everybody else is doing the same thing? Probably not a lot. So I'm thinking that hosts will not be able to earn a lot of data through this. Clearly, and we see some example how that works out in a free market right now. In Sirecoin, for example, you can get 1 terabyte of data for 1 month at the price of about 50 cents with a threefold redundancy built in already. Okay, so that is 10 times cheaper than what a commercial cloud service provider would do. I do not think this will be the case forever. So basically, I think from a user's perspective, you will be very happy to see you can use this very cheap cheaply. From a host perspective, you will just be happy that you can sell these extra resources for any price whatsoever. Yeah. So I think that answers your question.
Yes.
Last question.
Thank you. And the next question, if it becomes profitable for hosts, what prevents them for renting Amazon storage
So
and resell it?
Yeah, so what prevents them is their own risk perspective, because they have to provide a collateral, and the amount of collateral you lose, or the probability that you're going to lose, is proportional to the amount of other people who have the same failure condition as you at this time. So if you are doing this scenario where you as a host just resell it to Amazon, and Amazon has a problem, you will lose all your money. And that is a risk you're not willing to take. So you would rather host it yourself and be just dependent on what you are doing, because in this case you might have a problem and you can have somebody else step in much cheaper, and you will have a much better loss scenario in this case. So I think this scenario drives the decentralization aspect a lot, because as soon as you have the same failure conditions, you have a higher expectation of failure. So I think this will lead to a scenario where people will be incentivized to have also independent implementations, even of the software stack, to have this kind of resiliency, because people are loss aware.
Andreas, amazing work.
Yeah, thank you very much.
Good job. Everyone, give him a big hand.
Yeah, if you are interested, I'm here the whole day, and we can talk about it.
Good job. Thank you.